Hello, this is question 2 from the 2021 MAT. In this question, you may use without proof the following fact. We've got some expansion here of natural log of 1 minus x for any x with mod x less than 1. Right. Part 1, by choosing a particular value of x with mod x less than 1, show that that is an expansion there for log 2. So we can't use x is minus 1 because mod x has to be less than 1. Well, if we want to get at log 2 and we can't have log 2 directly, log of a half is a good alternative. So let's go with that then. I think that's going to be the way to go. So if we have x is a half, then that's going to lead us to natural log of a half, which is minus natural log 2. So actually, this expansion's all got minus signs on the right hand side, so we can drop all the minus signs and say that natural log 2 is going to be a half plus a half squared times 2, so an eighth, plus an eighth times a third, so a 24th, plus, what's that, 64 on that one, 1 over 64, plus etc, etc. Oh, they've written it out in a way. I should have taken more attention, paid more attention to how they've written it out. Right, they've written it out in a slightly different way on here. They've written it out as a 1 over n times 2 to the n. So that is a half plus 1 over 2 times 2 squared plus 1 over 3 times 2 cubed plus 1 over 4 times 2 to the 4. Etc. But either way, that's done part 1. Part 2. Use part 1 and the fact that we've got this inequality, 1 over n times 2 to the n. Okay, that's what we've just done. So that's what we've got here in this expansion, is less than 1 over 3 times 2 to the n. For n is greater than or equal to 4. Well, it would be. That's pretty obvious, but it might not be something we would have thought of using. I think that's more the point. We can see that that inequality must hold. Find the integer k such that log 2 lies between k over 24 and k plus 1 over 24. Right, and we've got this change here for n equals 4. This seems to be the dividing line here. So what's going on before that then? We've got a half plus an eighth plus a 24th. So that is going to be 12, 15, 16 over 24. So we've got log 2 is 16 over 24 plus some other sum of the rest. Right, well that's 16 over 24. Looks nice, pointing us to be a k equals to 16. How are we now going to get this upper limit then? Because we know that log 2 is now greater than 16 over 24. So that is something. How are we going to sum up this series? So this is the sum of 1 over n 2 to the n from n equals 4. I mean, we're gonna be subbing into that, aren't we, up to infinity? So we can't really do that anyway with a sum to infinity, because what's the ratio? We got an n and we got a 2 to the n. If we do, yeah, that's why this is going to be useful, because we just got a ratio of 2. If we change this other fraction that we've got here in this inequality, right, that will make sense then. So sum of the rest is going to be less than the sum of, well, from n equals 4 to infinity of 1 over 3 times 2 to the n. And this sum is going to be equal to, I mean, it doesn't necessarily matter, we're starting at 4, provided we get our first term, we can still do sum to infinity. So first term is going to be 1 over 3 times 16, so 1 over 48, divided by 1 minus a half. So 2 lots of that, so 1 over 24, perfect. So that means then that log 2, we know it's greater than 16 over 24, and then it's going to be less than 16 over 24 plus 1 over 24. So less than 17 over 24. Because this sum here that I've just done, this 1 over 24, well, that's more than we get for the rest of the sequence. So whatever we do end up getting for log 2 has got to be less than 16 over 24 plus that sum. Right, that was quite nice. Let's then get a new sheet up then, I think. Part 3, show that log 3 over 2 equals that, and deduce that log 3 equals that. Right, well, log 3 over 2 is going to be pretty easy, isn't it? We just put x is minus a half in. So x equals minus a half will give us natural log of 1.5. So let's put that in then. So we get log 3 over 2. So for minus a half, so we're going to get a half. And then let's make sure I'm not going to write this out the wrong way, having done what we did before. Well, we're going to get exactly the same, except the signs are going to be flipping. So every time we've got an even power, we're going to have a minus, and every time we've got an odd power, we're going to have a plus. So yeah, simple. I haven't really got much to show on this apart from, well, that's what it is. So I mean, it's pretty straightforward. So we're just writing out the answer really. Once you've put in x is minus a half into this, that's what you get. So deduce that log 3 is equal to this. Right, okay, no problemo. So we've got log 3 over 2 is equal to log 3 minus log 2. So log 3 is equal to log 3 over 2 plus log 2. And that means we've got, well, let's just add these two things together. We're adding these two up. So all of the even powers are going to cancel. And so we're going to get 1, then we're going to get plus, well, we're going to double each one. So we're going to lose a power of 2 on the bottom. So 1 over 3 times 2 squared plus 1 over 5 times 2 to the 4 plus etc. Right, that was fine. Part 4. Deduce that 13 over 12 is less than log 3 is less than 11 over 10. Right, this is the same thing. We've just done this in part 2, and we just have to do it again. So what are we doing then? Can we do exactly the same? But now we only have to add up the first 2 terms if we're doing this thing again. Because n greater than or equal to 4, that's going to be our dividing line, first 2 terms. So log 3 is equal to what we got, 1 plus 1 over 12, so that's 13 over 12, plus whatever comes next, so sum of the rest. So we've already got our lower limit there. We've got the 13 over 12. Now we've got this 11 over 10. So we're coming back to this. And we're starting with 1 over 5 times 2 to the 4. Now, what's going to be the best way of doing this? Well, I mean, that still holds. We can still say that, well, that is going to be less than 1 over 3 times 2 to the 4. That's definitely the case. So do I just sub back in for that again? Or, well, I suppose just give it a go, see what happens. Is that going to give me the number I want? So we do that sum is going to be less than the sum. So our first term is going to be, well, whatever that was again. That was 1 over 48. Is that 1 over 48? Yeah, it's 1 over 48. And then we're going, well, this time we've got a multiplier of a quarter rather than a half. So we'll have 3/4 on the bottom. So that's going to be put the 4 on top, the 3 on the bottom, so 1 over 36. That really, yeah, actually that fits with, if we add that to the 13 over 12 plus 1 over 36, so that's 40 over 36. Right, that's not come out at 11 over 10. 40 over 36. Yeah, that hasn't worked, has it? Yeah, don't really know what to So what value do we want instead on this? I mean, that's 1 and a 9th. That's 1 and a 10th. So, well, that's, I mean, it is then less than that, isn't it? If we put them over the same, I'm just wondering how they ended up with 11 over 10. What have they done that's different on this? If we had those over a common denominator, then like that's 400 over 360. And then if we did that, and we're saying it's less than that, oh, actually, this is going to be slightly better than that, isn't it? If we do top and bottom by 36, then we're getting 396. Right, so I need to make something slightly tighter than this. I've got a slightly larger upper bound, so that's no good. So what can we actually say then? Rather than doing this 1 over 3 times 2 to the n, it's, well, maybe go 1 over 5 times 2 to the n. I mean, that would work, wouldn't it? Because if we're doing 1 over 5 times 2 to the 4, yeah, I mean, we could change this 3 to a 5 here, this 3 in this inequality. If we had a 5, it would still be okay for, yeah, for adding up that series, because we'd be, then it would be exactly the same for this if we've got a 5 there, and all subsequent terms would be a bit bigger. So I could try doing this again with a 5 rather than a 3, and that will tighten our upper bound a bit. So let's try this again and say we've got, what would that would be 80, 1 over 80, and we still got the 3/4. So that would be 1 over 60, and 1 over 60 plus 13 over 12. So multiply that by 5, 65, 66 over 60. So yeah, we get our 11 over 10. Right, okay, so that was just tweaking it a little bit. And that then gives us our final result of 13 over 12 less than log 3 less than 11 over 10. Right, okay, yeah, that was fine. So it was a little bit different to part 2. But yeah, it's just bringing in that limit a little bit more by changing that 3 to a 5. Okay, last part, which is larger? 3 to the 17 or 4 to the 13? Without calculating either number, justify your answer. Pretty sure that's going to be 3 to the 17. Powers normally win when they're that far apart, but we can't just assume. So this is essentially what we're going to be just having worked out, isn't it? So we'll say that 3 to the 17, so we want to log this. So we've got 17 log 3 versus 13 log 4, which is 26 log 2. Right, and we've got our ranges for each one of these. So 17 log 3 is between these bounds. So 13 times 17 over 12 and 11 times 17 over 10. And we've got 26 log 2 is between, what did we have, 16 on this, didn't we? So we've got 16 times 26 over 24. Is that right? Yeah. And we've got 17 times 26 over 24. Right, these are slightly awkward looking numbers, although we've got 2 24s and a 12 here. Let's get this one over 24. So 24, 26. Oh, we got the same ones. These are the same. Right, so the 17 log 3 is greater than it. 26 log 2 is less than it. Perfect. So 26 log 2 is less than 17 times 26 over 24, and that is less than 17 log 3. So therefore, 3 to the power of 17 is greater than 4 to the power of 13. Right, that was a nice way to finish off. Right, that was relatively easy question 2, I would say. The first couple of parts were pretty straightforward. Little bit of a sneaky bit. I mean, part 3, they just got us to repeat it. Part 3 was weirdly quick. Part 4 had a little thing to spot of how to tighten in that upper bound. But yeah, Part 5 was fine. We'd done all the hard work. So there weren't too many things to get tripped up on that. You know, still not an absolute gimme, but as question 2s go, that was pretty good.